and you are in 6th grade. Okay, so here what you see is this iPad. This is recording whatever I'm doing right now. The purpose of this iPad is you don't have to worry about taking notes. Everything that I say in the class, you don't have to note it down. And you can focus more on understanding what I'm trying to explain. Because everything else is there for you to watch after the class. I'll send the video to your parents' ID and to their WhatsApp, and you can have access to this. Okay. So that's the main purpose. That's the main reason why I recorded, because whatever I'll explain now, you will remember this, understand this, but 2 days down the line, if you don't practice it, you'll forget it. That's where it helps. All right. So let me do a quick roll call and we'll get started. So we have Advik, Arab, we have Molina, right? Did I say it right this time, Beta? Milana. Okay. I'm getting old. Sorry about that. Milana. Okay. Then we have Hiranya, Dichita, Myra, Suhina, Urvi, Tansi, Vasundhara, and Adya as well. And in the classroom we have Manas. Sir, if you want, you can take a chair and sit down. I mean, you can see how boring it gets for the kids. All right? You can take a chair. Sir. Yeah. So, what are we going to learn today? That's $1 million question. And nobody gets $1 million for answering it either. Yeah? So, we will focus on learning about the linear models and look at what is meaning of linear graph and look at some word problems, and then we'll do some modeling using tables, equation and graphs, and then deal with some linear equation word problems. Does that sound okay, or sounds very cryptic to begin with? So that is here, but he's not here, okay? You're only with me for next 1 hour. Alright? Okay. So let's first try to understand what do you mean by linear graph. Does everybody know what is a linear graph? No? I also don't know. What I mean, it will be really fun if you're in a class and you don't know something and your teacher also doesn't know something. What will happen? There will be only one thing that will happen, that is called blabbering. And we'll not do blabbering here. Alright? So Milana, I'm trying my best to pronounce your name right, but okay. Don't get me wrong. Alright, Saurya, any idea what we mean by linear graph? Everybody knows about it, I believe. Except some of us, who is trying to recall. Suhina? Yep. Yadya, go ahead.
A linear graph, it's kind of like a bar graph to the side, but it kind of tracks I don't know how to explain it, but it might go up and down. I think there might be a scale in it.
Okay.
I don't know how to explain it.
Okay.
It'll keep working.
Okay. How about Arav?
Basically, linear equation is where two linear equation makes shapes coordinates to a graph.
Okay. So graph, you do it on a graph paper. You would have seen those, right? I mean, those paper where you have these kind of drawings done, right? And then you plot something on it, right? Which we call as coordinate plane. So now I always say that math as a subject has parents, like we all have, right? Who is math's parents? English. English is math's parent. That's what I call it. Meaning, the intention here is when you look at linear graph, any word, any term that you come across, you have to understand the literal meaning of it, and then you'll be able to relate it better. Let's look at linear graph. Linear and graph, these are two words. Graph. This is a graph paper. Okay, I'm just putting it here. And again, you look at linear, you have a line in it. Line and then something here. Yeah? Meaning on the graph paper, something that draws a line That's what we're talking about. Yeah? If I have graph paper, if I draw something like this, is this a line? No, it's a curve. So when you are talking about a situation, when you are drawing a line on a graph paper, you are talking about a situation which is nothing but linear graph. Is that okay? Everybody okay so far? Now, the other thing that you have to keep in mind is linear graph. And Manas, you are in 6th grade. Yeah. So you will find this as a thing that you have not come across before. But don't worry about it. In this class, in next 1 year, from now till before your final exams happens or start test happens, we will cover all the concepts on math for 6th, 7th and 8th. So this is level 2. Okay. So it might look little loaded to you, but I will keep decoding it to make it simple. Okay. That's how I started saying, okay, linear graph. Let's not worry about linear graph. I'm talking about English. Graph and a line. That's what makes it linear graph. Okay. Now, when you're talking about a line, what do you need for drawing a line?
A pencil.
Okay, what else? Yes, Adya.
For a line, you're gonna need the slope and the XY coordinate thing. I kind of forgot the name. Yeah.
Oh yeah. I will make it even simpler. Yes, Arav. Give me a very simple definition. Remember one thing, your teacher is not intelligent. I've been reminding you guys over and over again. What do you need for a line?
Basically, you need to know where the direction of the line is going and how steep it is, what the slope is.
Okay, Arihan.
For a line, right?
Yeah? What do you need for a line? For drawing a line?
2 points that go.
Exactly, that's what I was saying. You guys keep on giving me difficult answers. I need simple answers. What do you need for drawing a line? Manas, you need just 2 points for drawing a line. If I have these 2 points, I can just join them and I will draw a line. If somebody gives up 1 point and says draw a line, I can draw a line, but that will not be one finite line. I can draw multiple lines that is crossing that point, but there is no one line. But if I have 2 points given to me, there is one and only one line that I can draw through that. Right? So guys, don't make your life and my life equal difficult by giving me cryptic answers. I'm always leaning towards simpler answers, okay? So don't go into complexities. When we have a problem to solve, we'll look at the easy way to interpret it and then use it. And then we'll try relating that with math concept, okay? Yeah? So now we know that, okay, we need 2 points for drawing a line. Clear? So we are talking about linear graph. Now, so meaning a graph which has a line. Now, second thing we learned is we need at least 2 points. Now, if I have 3 points and it passes through that, a line passes through that is also fine. Nobody is getting hurt. But I need minimum 2 points for drawing a line. Correct? So far that is okay? Mm-hmm. And once I draw a line, how many points I am talking about? In this small line, how many points we are talking about? Urvi? Manas? 2? No, I have already drawn a line. See, imagine this. You guys have to explore your imagination. How many points we are talking about? So many points, so many points. I cannot even count them.
Maybe that's like a lot.
A million, maybe 2 millions. Yeah? So basically, I need just 2 points to draw a line, and once I have a line, I have so many points that is on the line actually. Yeah? Am I making sense so far, or I'm just... Okay. Alright. So, now with this understanding, there's one more understanding that you guys have learned long time ago. But I will just help you guys recall it again. If I'm talking about what is the main purpose of this graph or the coordinate plane, we call it a coordinate plane. because you have an x-axis here, you have a y-axis here. We call it a coordinate plane, correct? Yeah, remember? What is the main purpose of the coordinate plane? What does it actually help with?
It helps with board graphs, I
Okay, Arihan?
Helps with putting like a coordinate on a coordinate plane.
It helps you locate points. If any of you need to come to the classroom, what do you need? You need an address, correct? Can I say, come to the classroom in McKinney? You cannot reach the classroom. What you need is exact address. So the coordinate plane actually helps you. Imagine you drawing something on the board without the coordinate plane. I have no ways to differentiate between this point and this point on the board. I have no ways to locate it, no ways to identify these 2 points. Okay? The coordinate plane helps you to split this and create address for these guys. Now when you have this point and this point, you will say 1, 2, 3, 4, 5, 6 here, -1, -2, -3, -4, -5, let's say. Here -1, 1, 2, 3, 4, 5, 6, -1, -2, -3. Okay. Now, with the coordinate plane coming into play, you have a way to locate these points. Meaning, you will say, okay, this point has an address along the x-axis. This is my x-axis, this is my y-axis. Or in layman's term, I will say this is my number line, horizontal number line, and this is my vertical number line. Yeah? Everybody remembers the number line, correct?
Yeah.
So now this horizontal number line, I will call it x-axis. The vertical number line, I will call it y-axis. Now this point is closer to -5 along the x-axis, and 1, 2, -3, maybe. Okay, this is -5 along the x-axis and -3 along the y-axis. I have an address for this guy. On the coordinate plane, -5, -3 is a fixed place. You can locate this point. Likewise, this point you should locate, you say, okay, how much on the x-axis and how much on the y-axis. Here it is 6, 1, 2, 3, 4, 5, 6. Okay. So this is, first you will write the x value, it is +6, and what is the y value? It is +6. So 6, 6 is this point, -5, 3 is this point on the graph paper. It helps you locate these 2 points, right? So now, if you are talking about drawing a line, you have 2 points, you connect them. This is your line. Am I connecting the dots for you guys or no? Yeah? Making sense so far?
Mm-hmm.
So, let's take this information and go into depth of what we are wanting to cover. But what is a good prelude to start with? Are we all understanding this in the simplest possible way? Urvi, Myra, Arav, Advik, Manas, Vasundhara, everybody? Shaurya? Hiranya? Everybody, right? Okay. I said everybody, and I'm assuming everybody. So, what we wanted to cover this week were these topics. So let me read it for you guys. We wanted to cover linear graph and word problem, modeling with table equation and graphs, and linear equation word problems. So, now we know what is graph, what is a linear graph, and we also recalled what do we mean, where does the coordinate plane help us. So, tomorrow, let's say somebody says, you are given some x and y value, okay? I need only 2 points for drawing a line. Let's say somebody says x equal to 3, y equal to 5, x equal to 2, y equal to 9. So this, look at the pair. This is XY pair, one point. This is XY pair, another point. In a table form, if you are given this information, would you be able to draw a line?
No.
No? Think about it. Yes, Suina.
You were able to draw it because you have the x's and the y-axis, and it would be easy to locate the location by the graph.
Yeah. Arihan, what do you think?
Yes, because you have you have 2 points and you know where those 2 points are.
Right. So when you have a table like this, yes, Sadia.
I was about to say.
Same thing. Somebody borrowed your thoughts. No, it's the same thing. I mean, conceptually it's the same, right? So as long as we are all clear about it, we are fine. So when you have a table like this, okay, information in this tabular form, which is giving you some x and y values, okay. So look at each and every pair of the information. This is one pair of x and y value. This is another pair of x and y value in this table. You can use this information to draw a line. So now look at this. If I'm talking about this graph, 1, 2, 3, 4, 5, minus 1, minus 2, minus 3, minus 4, minus 5. And this side, let's use bigger scale. I will say 3, 6, 9, minus 3, minus 6, minus 9. My first point is 3, 5. X is 3, y is 5. When x is 3, y is 5. I'm talking about probably this point. When x is 2, y is 9. When x is 2, y is 9. So, I'm talking about this point. I have 2 points. I can join these two and I have drawn a line. Hello, beta. Hello. What's your name, beta?
Vidanshi.
Say that again.
Vidanshi.
Vidanshi. So you can move a little bit this side so that you can see it better, and I can see your reaction as well. So, ma'am, if you want to sit down, you can take a chair and sit down and see how I'm wasting everybody's time. Yeah. Okay. All right. So in today's class, what we are doing is we are learning linear graphs. How do you relate linear graphs with the word problems, and deal with the correlation between the understanding of tables, graphs, and the word problems together. Okay. So between today and tomorrow, we'll muddle the water around these concepts and see how that helps. Okay. So far what we have done is we looked at 2-3 things. One is, why do we need a graph paper? Why do we need a graph? It helps us locate the points. You have seen you are comfortable with the graphs? Huh? Are you comfortable with the graphs?
Yeah.
Okay. So we know graph helps us locate the points along the x and y axis or against the x and y axis. Second thing we said, okay, if you have to draw a line, what is the minimum we need? We need 2 points. Any 2 points. I can connect them to draw a line. Yep. And now when we are marrying these 2 concepts together, we see that, okay, fine. If I have 2 points, I know these are 2 points. And I can connect these 2 to draw a line, and I have ways to locate these 2 points also. So these 2 points have their own identity in terms of x and y coordinate, and that is what we are seeing in this table. Yep. Is everybody clear so far? Milana, Saurya, Vasundhara, everybody? Myra?
Yes.
Tansi? Vidansi, right? Yeah. Okay.
Yes.
So I am very good at making mistakes. Meaning, I will mess up with your name a couple of times before I memorize it well. So bear with me, but okay, there is no intent. It's just a problem with the gray hairs that comes along. Okay. All right. So everybody clear so far? So now, without me giving any further theory, let's look at some legitimate problems and see if we have the basic knowledge to solve these problems or not. And again, this class, our only goal would be to simplify things. If I ever say anything cryptic or complicated, stop me then and there. Okay. because now Advik and Arav, Moira, Suhina, everybody will start crying because I'm going to say something that they have heard at least 100 times. Okay? So there's a concept. Suhina is already smiling. There's a concept that I recommend to all the kids. I have derived this for you guys, or I have kind of connected the dots. I call it the silver bullet for solving any problem. See, Arihan is also crying. So this, if you look at the story of this, I call this who wins the race, who ran the best. Yeah? If you are in a race, competing, doing some cross country, who wins it depends on who ran the best. Now, we are not doing any race here, but there is a concept here. RAN. R stands for read, A stands for analyze, and N stands for Nike. Nike, as a shoe brand, you guys know. Nike's this logo, not logo. It's called punchline. Just do it. Yeah, that's what Nike says. Just do it. So read, analyze, and then do it. That's what it means. Meaning, if you have a problem to solve, any problem that you're trying to solve, don't, as soon as you get a question, don't jump onto solving it. Read the question once, twice, 3 times maybe. Get that question right. Then you put your thoughts together. Say, okay, fine. This is the question. This is what is given to me. These are the formulas I'm aware of. This is the approach I'm going to take. So you have made your mind. You have not touched your pen yet. You are still putting your thoughts together. So read, analyze, and then Nike. Then do it. So in short, what I recommend you guys is, when you have a problem to solve, read it, think through it, and then you try solving it. Because the problem is, in the exam, you have very limited time. If you take a wrong path for solving a problem and you waste 15 minutes and then you realize, oh, I made a mistake, and then you come back, that 15 minutes that you lost will compromise your chances of doing 2 more problems that you would have done otherwise and gotten a better score. Okay? So that's why I say, don't jump onto solving any problem. Think through it, analyze it, and then you try doing it. Even if you are spending 30 seconds extra, you are potentially saving those 10 minutes that you would have wasted otherwise. Yeah? Does it make sense? Dikshita? You've heard it 200 times maybe. Okay, sorry about that. But yeah, this is something that I do with all the kids when they join. And for you guys also, I'm doing it on purpose because I want to keep on reminding you that don't forget this. This is going to become life for all of us. Yep? Alright? Urvi? Agreed?
Yeah.
Okay. So now with all the background work done, let's jump on to solving a problem, and don't forget RAN. You'll win the race if you ran the best. Let's look at one problem. I'm going to read this problem and then we'll try solving it together. I'll let you guys think through it, apply these RAN concepts and see whether it's working or not. So I'm reading let me draw it first. This is what is given in the question, okay? 0.5, 1, 1.5, 2, so on and so forth. And this is 5, minus 5, minus 10, 5, 10. Leave it here. Okay? This is the graph given, okay? So this is probably 1, no, 0.75. So this is my x-axis, this is my y-axis. I'm now reading the question, okay? So far, you guys have no clue what we are trying to do, okay? So this question says, Suraj took a slice of pizza from freezer and put it in the oven. Suraj, somebody, picked up a slice of pizza from the freezer and put it in the oven. The pizza's temperature in degrees Celsius as a function of time in minutes is graphed. So here what you are seeing is temperature. Here what you are seeing is time in minutes. The pizza's temperature in degrees Celsius is shown. So this is degrees Celsius, okay? And this is time in minutes. Is in the graph. Now the question is, how long did it take the pizza to reach 0 degrees Celsius? How long did it take for the pizza to reach 0 degrees Celsius? Now, this is the question in front of you. This is a graph. Here along this axis we are measuring time. So this is 0 minute, 0.5 minute, 1 minute, 1.5 minute, 2 minute. Here you are seeing 0 degree, 5 degree, 10 degree, keeps going. And this is minus 5 degree. So it says, how long did it take for the pizza to reach 0 degrees Celsius? Can you read this graph? Look at the graph. Stare at the graph. It will give you the clue. How long did it take? See again, I'm applying RAN. Read enough. How long did it take for the pizza to reach 0 degrees Celsius?
Wait, the answer is right in front of me.
Exactly, that's what I'm saying. Everybody got the question right? Everybody, Suhina, Myra, Arihan, Saurya, Dikshita, everybody, Advi, Karav. So now I've got enough thumbs up from you guys. I want to know what the answer is. Yes, Vidansi. Vidansi, sorry. 2-3 times. Yes, Arihan, tell me. How long did it take for the pizza to reach 0 degrees Celsius?
0.
It took 0 minutes to reach 0 degree?
No.
Okay, let's see what Suhina says. Yes, Suhina.
75. 0.
Say that one more time.
0 and 75.
0 and 75. Vasundhara.
It's not the answer, but I think I have to go now.
Okay, alright, done. You'll have to watch the video of the class later on.
Okay, I will.
Yeah, Arihan, go ahead. Bye, beta.
I have a question. Is the y-axis, is that in Fahrenheit or Celsius? It's right there.
Yes, that's what.
It's 6 Celsius, I think.
Yes, Saurya.
It's 0.75.
0.75. No, you have to be very, very explicit with your answer, okay? Yeah, Dikshita, tell me.
I got 0 and 25. 75, sir.
What 75? Where is 75? No, see again, I'm not putting anybody on the spot. I want the very explicit and point blank answer.
Oh. No.
Urvi, tell me. Again, hear my question one more time. How long did it take for the pizza to reach 0 degrees Celsius?
So this is a question, actually. That 0.75, is it like on the x-axis or like the y-axis? Or is it like where the point is?
Okay. I will come to that, but I'm not answering that because I want everybody to think. Yes, Arav.
Okay.
45 seconds.
45 seconds. Okay. How about, yes, Manas, tell me, what do you think? Thinking. You said it is right in front of us, and I agree. We are just not thinking a little bit more. See, this RAN has 3 parts to it. Read, analyze. You guys have read it now because I said it so many times. So what I need from you guys is analyze. Because doing it would be easy peasy. Yes, Suhina.
I think an important thing is my x-axis.
Tell me what it is.
I want to change it to 5 seconds.
5 seconds. Okay. Yes, Dikshita.
I got 15 seconds.
15 seconds.
Yes.
Okay. Now, I will not do anything magical because Vidansi will be sad to know that her teacher is not intelligent. That's what I keep telling. I don't claim to be intelligent. Because the day I claim so, I will make things complicated. And we'll keep this simple here. Now, I'm going to do the same thing like what I was expecting you guys to do. So this was the graph given, which says along the x-axis I have time in minutes, and along the y-axis I have the temperature increase, or temperature of pizza which is kept in the oven. Now if I'm reading it, when the time is 0, meaning initially when time had not changed, okay, I had not started the oven, okay, before starting the oven, what was my temperature? Minus 5 degrees Celsius. This point, look at this point.
Oh, I was going to say that one.
But wait, we are not done yet.
Oh.
So when there was no time that has elapsed, the temperature was minus 5 degrees. The question was, how long did it take to reach the temperature 5 degrees? 0 degrees. Where is the temperature 0 degree? This is 0 degrees. Here, at this point, which is halfway through 0.5 and 1 minute. So 0.5 minute is 30 seconds, 1 minute is 60 seconds. Halfway through at 45 seconds. This is at this point when the time has elapsed 45 seconds, the temperature increased from minus 5 to 0. And then as the time progresses, temperature is increasing, as you can see. So from minus 5, it went to 0 degree during this time. Yeah? Vidansi, making sense better? Is it?
Yeah.
Yeah, okay. So basically it took 45 seconds to reach 0 degree. Now if somebody says, how long it took for reaching 5 degrees? I will see, okay fine, minus 5, oven turned on, temperature increasing, it went to 5 degrees at this point. Oh, it is somewhere between 60 seconds and 1.5 minutes, maybe 65 seconds. Yeah? How long it took to reach 10 degrees? Okay, 10 degrees. See, this graph is showing how things are changing. This is probably 2.5 minutes. So, it changed from here to here, minus 5 to 10 degrees in this much time. And this is 2.5 minutes, 150 seconds. Yeah? So this, when you look at this graph, I find graph is one of the easiest part of math because it literally tells you a story. Pick up any point. If you pick up this point, see what is the value of x? 1.5 minutes. What has been the temperature changed? What the temperature has changed to? Oh, this is 6 minutes. So basically, 6 degrees. So in 1.5 minutes, the temperature changed from minus 5 degrees to 6 degrees. You can look at every point on the graph, and that tells you how the temperature of the pizza is changing by putting in the oven and turning it on. Obviously, you have to turn it on. Just putting the pizza in the temperature would not change the temperature unless you turn it on. Yeah. Is it making sense so far? Is everybody with me? Yeah? Vidansi, sorry beta. Yeah, so I have some kids with different names. Your name is unique so far. There is nobody with your name. Even when I have close to 100 students now. So out of 100, there is nobody with name Vidansi. There is nobody with name Manas also. So you guys are first time with your name. All right. So is everybody clear?
Yes, sir.
There is nobody with name Arav also. Arabs don't cry. Adya also. I think Adya, I have 2 kids with name Adya.
Where are they fine?
I'm sorry?
Are they fine?
Just throwing some emojis here. Okay, let's pick up another question. Is everybody clear so far? Tansi, Arab, Advik, Shaurya, Arihan, Myra, Aradhya, Nihan. Okay, let's pick up the next question. Amir drove from Jerusalem to the lowest place on earth, the Dead Sea. Somebody named Amir drove from Jerusalem to the lowest place on earth, the Dead Sea. His altitude relative to the sea level in meters as a function of time in minutes is graphed below. So let me graph something that this story is about. So, again, everybody pay attention to what I'm saying. Every word of mine is worth $1 million. Nobody gets $1 million though. Let me read it one more time. Amir drove from Jerusalem to the lowest plain on earth. So somebody is driving from one place to another. Okay. His altitude. So it's like this. Somebody is driving at some place and it has an altitude. He is driving in a direction such that he goes to the place which has the lowest altitude. It's called Dead Sea. Who all has been to the Death Valley? Anybody? It's in California. It's a Death Valley National Park.
I've been to California, but not in
Death Valley. So Death Valley is the place. I mean, obviously it's called Death Valley for a reason. It has recorded the highest temperature ever in the history around the globe.
Yeah, it's the
Hottest place. Yeah. So there is a place which is the lowest place on earth, lowest altitude from the sea level. So every place is measured against the sea level. How far away you are from the sea level. So this place, if this place is on a higher altitude, the value will be higher. Saying okay, this place is like 200 feet from the sea level. So this place is lowest. So he's moving in a direction where his altitude is changing. Okay, that's what we'll keep in mind. His altitude related to the sea level is in meters is a function of time in minutes is graphed below. So this is the graph that is talking about 0, 160, 320, maybe 360, and this point is 350. This is 350. Okay, this point is going like this, and this is touching 16, 32, 48. So this is probably 40, this point. So if you look at this graph is saying that his altitude, so this is altitude, this is altitude, his altitude is change, this direction is altitude, this direction is time in minutes. So what this graph is showing is, he was at certain point, after 16 minutes his altitude changed to this, after 32 minutes his altitude changed to this point, after 40 minutes his altitude changed to this point. Now the question is, how long was each descent by 88 meters? How long was each descent by 88 meters? Meaning how long it took for him to reduce his altitude by 88 meters. And the options given are 8 minutes, 10 minutes, 44 minutes, and 11 minutes. So let me repeat the question one last time. Somebody is moving from one place to the lowest place on the earth in terms of altitude or the height from the sea level. Okay. So every point that you see is the height from the sea level. So he is moving in a direction where his altitude is decreasing. So the question is, how long it took for him to descend by 88 meters. So here all this that you see is in meters. Okay. At this point it was 350 meters. After 16 minutes it was somewhere around maybe 320 meters. After this many minutes it was somewhere around 160 meters. After 40 minutes it came down to 0 meters. So the question is, how long it took for him to descend by 88 meters? Average. You'll need some calculation. Maybe using your pen and paper. Vidansi, think about it. Everybody got the question, right?
Yes.
Kind of? Tansi, Saurya? I'm sorry, what?
Do I show that?
No, you have to draw it. I mean, you can look at the calculation part of it.
So 360 subtracted by 88.
So how would you guys approach this problem? Anybody has any thought?
Well, it's
No. Let me read this question one last time before.
wait.
Yeah. So, are you guys clear about this question, or you want me to repeat this question?
Oh, so we need to divide this?
So let me read this question one last time, because I strongly believe that when you read a question couple of times, the question becomes easier. Oh, Vidansi, I forgot to give it to you, beta.
Oh, it's okay.
Yeah, you fine?
Yeah.
This, okay. As long as mosquitoes are not coming closer to you. Yeah. So the question is, somebody drove from a place to another place, which is lowest place on earth, called Dead Sea. His altitude relative to time in meters as a function of time. So when time is increasing, his altitude is decreasing. Is graph below. It says, how long was each descent by 88 meters? For every descent of 88 meters, how much time it took? And we are given 4 options: 8 minutes, 10 minutes, 44 minutes, or 11 minutes.
I'm guessing it's B.
You are guessing?
I think it's C.
You think it's C? Okay. And again, I don't mind you guys guessing, but it has to be a very thoughtful guess. So I would want you to tell me why you think so. I'll come to you. I'll come to you. I'll let everybody answer this question first, and then I'll pick your brain to understand what made you get to that as an answer. Okay. Okay. Saurya, Aradhya, Adya, Milana, what's happening? Dikshita, Myra, Nihan, no answers so far. Abhi,
I'm still thinking.
Okay, let me. Okay, first you tell me. You said you think it's B, and you said you think it's C. Tell me the story. Tell me what made you believe that this is the answer? And again, I'm not contesting whether this is right or not. I'm just trying to understand how did you approach to get to that answer.
I think it's B, because if you really look at the graph, it says that. So when I checked, my calculations told me it was 10. I mean, it was B. So that's
Okay. Vidansi, tell me that.
So if you're on like Jerusalem, which is like Israel, then you then like it's always going to be like a big number. So I was like, okay, the biggest number should probably be the right one. Because think about it, like Jerusalem, that's an Israel, and then the lowest point would be like not Antarctica, and I don't know where it is, but yeah, it's gonna take some time to get there. Like Jerusalem, if it's already regarded for being, it's not regarded for being the lowest point on Earth, but close to the lowest point, so it can't be that close. It's like 10 minutes.
Okay. Anybody on the screen wants to give me a story? Arab is crying. See, you guys have to tell me a story. See, even if you're not able to solve it, at least you have to have an approach. Correct? Now, see, why did we have this graph in place? Because this is giving data to substantiate what we are trying to say or what we are trying to interpret. He's going from one place to another place. He can go from some other place also. But to your point, Vidansi, he's going to the lowest point, but it is not saying that he's going at a very fast speed. He might be going slow also. Here it's given in minutes. Tomorrow if the graph changes, say, okay, it is not minutes, it is days. I don't mind. It's okay. That guy is taking it easy, going slow. So my interpretation or my calculation would be based on the data that I have in front of me. Okay. Now let's look at it. Everybody here, everybody pay attention. This graph. So everybody is clear about the question first place, right? Everybody is clear about the question, right? Urvi, clear beta? Okay. Abhi, clear? Question is clear, right? Question has to be clear, right? Then only we'll talk about the answer. So this graph is saying, this graph is representing how is the altitude changing with time. Now this graph has a story to it. If I look at it, I know I did not do a perfect drawing based on what we had in the question, but somewhat closer to this. If I read it by its face value, when it's 0 minutes, his altitude is 350 meters. Meaning when he has not started, he is in a place where the altitude is 350 meters. After 16 minutes, his altitude changed to 320. See, he is moving and his altitude is decreasing. After, let's say here, 16 and 32, maybe this is 24. After 24 minutes, his altitude changed to 160. Okay? After 32 minutes, his altitude maybe changed to 120 or something. After this many minutes, between 32 and 48, maybe this is 40. At 40, his altitude changed to 0. His altitude is decreasing, right? His altitude decreased to 0 value. So after 40 minutes, his altitude is 0. So it changed from 350 to 0 in how many minutes? 40 minutes. So in 40 minutes, it changed by 350. It was 350 before, it came to 0. So it took 40 minutes to change to 350 by 350. It reduced by 350 in 40 minutes. If he goes at the same pace, it will keep on decreasing. Am I making sense so far? Vidanshi, okay with that? Urvi, Abhi, Arav, Advik, Myra, everybody? Arihan? I'm just narrating the story that this graph tells us. That from 350 it came to 0 altitude in 40 minutes by spending this much time. So in 40 minutes it reduced by 350. If I use that as an average, in 1 minute it will reduce by how much? 350 by 40. What is being asked? It says, okay, for 88 meters, how much time it will take? Oh, I have to think otherwise. For 350 meters, it took 40 minutes. How much it will take for 88 meters? So let me rewrite this for you guys. So from this graph, what we saw was, for 350 meters, for it to change its altitude by 350 meters, it took 40 minutes. So for 1 meter, For the altitude to change by 1 meter, it will take 40 divided by 350 minutes. For 88 meters, 40 divided by 350 multiplied by 88. And again, I know this doesn't look like an easy calculation.
Let me try.
But this is, I'll do a rough calculation here. I'll do estimation, okay? So this is 40 into 88 will turn to 90. And then 350 will remain 350. I'm talking about 40 times 90. Oh, this is 40 times 9. 4 times 9 is 36 and 2 zeros. Divide by 350. It is more than 10. But this is the option that I'm leaning towards. This is way too high, this is less, and this is less. Did that make sense?
Yeah.
So, see again, if you try doing the calculation to get the exact value, that would not work. You already have 4 options to choose from. You have to find out which one it is closest to. And that you can find out by doing approximation. Yeah?
86.
86?
I'm getting 187. I'm still on the division for a 33 by 40. But into 88. So like so 48 you cancel out to 35, so I did 1, and then you just get it right, then 35, bring down 0. Subtracting from 320 because 48 times 8 is 320, and you get 30, and then you bring another 0 down, and you get 280, because 40 times 7 is 280.
Here it is you are at 350 divided by 350. You are dividing by 40. No, so see, here's the thing. You have to multiply these two and divide that by 350. And again, since we have the options given here, we don't have to do exact calculation because that will take long time. So what we are doing is round it, do the estimation. 40 remains 40, 88, let's round it to 2 digits. That becomes 90. 40 into 90 divided by 350. So 40 into 90 is what? 3600. 4 times 9 is 36 and then 2 zeros and divide by 350. So 3600 by 350 will give you, if it was 3500, it would have given you a perfect 100. Perfect 10, sorry. It is little more than that. So it will be more than 10. So 11. That's the closest number. Yeah? Yes, Arihan.
I did it a different way, but I got the same answer. So I'm just checking if it was just a lucky guess or
I got 86 into 88 is 7,562.
What are you doing here?
For my answer, I got 3.
No, so see the answer is here. So what I was just telling you guys that now look at this graph. Again, I'm reading it from beginning. It changed altitude from 3500 to 0 in this much time, which is nothing but 40 minutes. So it took 40 minutes to change from 350 to 20. So 350 meters changes in 40 minutes. 1 meter will change in how much? This divided by this, right? It's like 10 potatoes come for $20. 1 potato will come for 20 by 10. So this 10 is coming here. This 350 is coming here. So 1 meter descent is happening in this many minutes. So the question is, how much time it takes for 88 meters descent? So 1 takes this much, 88 will take this much into 88. And that's what we are calculating here. 40 into 88. This 88 I am rounding it because I don't want to get a perfect value. Okay, I don't want to get 10.96 or something. As long as I see something closer to one of these values, that's what my answer would be, right? Because we have the answer given. If somebody says calculate, then you have to do that much. Otherwise, you can use estimation technique to get the nearest possible right answer. Yes, Arihan, go ahead.
I got the same answer, but I did it a different way. So I'm just
And that was, can you tell your story?
Yeah, so I didn't see the negative 40. I don't know what happened. So
Wait,
I did 350
Nice again.
minus 160,
Uh-huh.
and I got 190.
Uh-huh.
And then I divided that by 30 to get like a rough estimate.
Okay.
5, and then I did 88 divided by that, and I got 11.
Okay. So ultimate.
It's a rough estimate from 10.
Correct. So again, now look at it a little differently. If you see a line, it has a slope. Yeah. This slope, if it's horizontal, less slope. If it is like this, it's a high slope or more steep. So here, this is a linear flow. That's right. It says find out how much time it takes. Mosquito?
Yeah.
Okay. So that's why you guys have the bracelet. So here, when you see this one, you have to find out at what rate I'm decreasing. So you can pick any 2 points and see for changing from here to here how much time it took. Once you know that okay, for changing this much, this much distance, it took this much time. So for this much, it will take how much? So it's just about applying the algebra concept to extrapolate or interpolate based on the information you have. So any and every graph that you see, it is nothing but it tells you a story. As long as you are able to decode that story and get the meaningful information out of it, you can apply it. Yes.
So the answer is 11, right?
Yep.
Oh.
And for Manas and for Vidyanshi. Vidyanshi, right?
Vidanshi.
Vidyanshi.
Yeah.
I am a very stupid teacher. When I say so, I'm one of the teachers who doesn't really care about the answer. So like, when I hear you guys say, okay, oh, this is the answer, right? Maybe, may not be, I don't care. I don't care. By that, what I mean is, I'm focusing more on making sure that you guys understand the concept or the approach part. Once you're clear about the approach, you can solve problems of similar nature 100 times or 100 different problems at the same time. So what has to be rock solid is the approach that you take. Yeah? Adya, you agree? It's always the approach that matters. Your answer could change, problem could change. As long as we are thorough and clear and confident about the approach, math will remain a cakewalk. So whatever we did today, that was for today. We have come to the end of the class. And see if anybody has any question before I let you guys go. So tomorrow we are going to muddle the water more and solve few more problems relating to these concepts, because math will remain easy if we practice enough. And remember, Vidanshi and Manas, RAN is something that will get glued to you till you do math. So we'll keep applying that concept because that helps. Whenever you have problem to solve, read it a couple of times, you will see that you have a better understanding of the problem, and then solving becomes much easier otherwise.
Yes, sir.
Yep. Alright, with that being said, I'll let you guys go. Enjoy the rest of the evening. Talk to you guys tomorrow same time.
Bye.
Bye-bye.
Next time.
Bye-bye.
Yes, sir.